Still in my cricket over there. All right, so they give you 2 points. So let's kind of review lines a little bit since we got this question. Number 14, they give you -2, 1, and 1, 5. And they ask you to find the equation of the line through those 2 points. So what equations of lines do you know? One of them. Yeah. So you guys, that's one of them. And this is the what now? This is the slope. And this is the intercept, kick ass. I like it. And there's another one. I don't know if you guys know the other. Y minus? Oh, okay, I see what you're thinking about. This equation comes from the equation for slope. Slope, of course, is, what is it in English? Rise over run. And when you rise or fall, you change the y's. And thank God it rhymes. Rise, y's. Right? Rise over run the other guys, is what I say. So rise would be how much your y's change. Run would be how much your x's change. Okay, so real quick, this is not me teaching you this, just reminding you this. Doesn't matter what points I pick. No. So I can say, let this one be any point that it wants to be, and this one is some given point. And look what you get when you multiply this up, you get this. So that's where it comes from. That's where that equation comes from. This is useful if I don't know the y-intercept. I can know any point, and I can just plug the parts in. That's why that one's useful. That's why we created it. I like it. So, for example, this problem, do I know the y-intercept? Do I? No. If it was a y-intercept, it would have to start with, what number would be here? 0. Because that would make it be on the y-axis. You don't go left or right at all, you would be on the y-axis. Maybe. And that, of course, is why b is the y-intercept. What do you get when you make x 0? You get, what do you get when you make x 0 here? You get, when you make x 0, you get the thing I'm not covering to b. All right, let me slow down. All right. If you make x 0, m times 0 is 0. I don't care what m is. So you get y equals b. Right? So that's why b is the y-intercept. I like it. Cool. So I know 2 points. And for this equation to work, I just need 1 point. So I can pick either one. A line goes through how many points? Infinite number of points. So which ones do I have to use? Well, I can use any of them I want to. I know 2 of them. I can pick one. What's the only thing I don't know then that I need for this equation? I need this. I got it. Check. What else do I need? Slope. And I know how to figure out the slope. Right? We put this back to normal. The subscripts, the only reason the subscripts are there is so that you go the same order. Right? How do I get the slope between these points? Yeah, if you do 5 minus 1, the bottom better be 1 minus -2. You have to go the same order, or else you're going to get the wrong sign. Your slope is going to be going down instead of up or something. That's the only reason we have these stupid little subscripts, is whatever you call the second point, both of its parts better come first, or else you're going to get the wrong direction. All right, let me stop there for a second. People are always thrown off by these poor little subscript dudes, and all they're trying to say is, go the same way. Dear God. Right? So if you do 5 minus 1, that's the change in your y's. And so you have to do 1 minus -2. Yeah. 4, this becomes plus, thirds. I like it. So what if somebody else would have been, I don't want to do this yet, I want to do 1 minus 5. All right, well, that's great. Well, you better do freaking -2 minus 1. You got to go the same way. And sure enough, you get -4 over -3, which is still 4 freaking thirds. Yeah, so that's all the little subscripts mean, is just go the same way. That's enough for me to do. I think you guys are familiar. You got the slope now. You've got whichever point you want to use. Just got to plug it all in there. Right? So I've got a few people looking at me like I'm crazy. What goes here? Yeah, because the slope is 4/3. The reason we use the letter M is it's a French word, marcher, for walk. So slope is sort of like how you walk. So that's why slope is M. You're like, what the hell is slope M? X minus what? What goes here? Well, it depends. Which point do you want to use? If you want to use this one, you're going to put 1. And this will be y minus 5. Cool. Now, if you use this point instead, you're going to end up with the exact same answer, believe it or not. Right? So that one you can just simplify it, solve for y, put it in the mx plus b form. That's the kind of better form, a little more compact. Is this coming back to you guys? Is this all right? Okay. Yeah.
While we're on the topic, if you do 12, it's just a quick one. I just want to make sure that I have it right. It's y equals -2. So does that just mean there's no slope?
Oh, yeah. So it says graph the line. If I said y must be, what is it again? -2. So if I say y has to be -2, so give me some points that's true for.
1, -2, 2, -2.
1, -2, 2, -2,
-1.
0, -2, right? So what's true about every one of those? So 1, -2, 2, -2, 0, -2. So obviously it's going to be, so I really want this to make sense. When I change y, I go up and down, because that's what the freaking y-axis does. This says y cannot change. Y must be -2. Does this equation say shit about x? So what can x do? Anything it wants to. It can be everything. So y has to be -2, meaning it cannot go up or down. But x can be anything it wants to be. So the only way it can move is left and right. So what would an x equals equation look like? What do you think? If a y equals is straight this way, and x equals is straight this way. I love it. So x equals 3 would be this, because x has to stay at 3. It can't go left and right. It has to stay at 3. So those are two special cases.
Do they both have a slope of 0?
No. This has a slope of 0. Right? Nice flat ground. This would be, extreme mountain climbing. This has either undefined slope, or somebody else have a different word for it. It just goes straight up forever. Infinite slope. Right? So this would be undefined or infinite slope. And let's see why. What is slope again? It's rise over run. So if I rise 1 and I run how much? How much do I move away from there where my finger is? None, right? How much do I run? 0. So wouldn't it be 1 over 0? What is 1 over 0? Undefined is what most of us know. Or some of us realize, some of our teachers have told us that's a form of infinity. It's an infinite thing. I like it. All right, I love it. I always freak some of you guys out right off the bat. You're like, what the fuck? All right, so anything else about slow stuff? So rise over run, rise rhymes with wise. That's awesome. Yeah.
Can you just finish that? Because I feel like that calms down.
Oh, sure. What could I do with the 4/3? Yeah. So y minus 5. 4/3 x minus 4/3. Add the 5, get LCD. Right? Kind of the best form for a line to be in is y equals mx plus b, because it is so compact. And then I can see the y-intercept, for example. Right? So go ahead and solve that bad boy for y. Add 5. Get LCD. So you can put those together.
Oh, okay.
Yeah, good. Yeah.
And how about x?
What about x?
Are we gonna just leave x by itself or y? I don't know.
So you get y equals 4/3 x, and then whatever you get there, right?
Okay.
So you'll see the slope, and then you'll see the y-intercept, whatever that comes out to be.
Okay.
So the y-intercept here is going to be a little bit gross. Not the prettiest thing in the world, but poor little dude, it still is a number. I like it. All right. The cricket just lives here, so I don't know if you guys can hear that. Okay, cool. I like it. Yeah.
Can you remember 30?
Oh, okay. Yeah, this is going to be a part of what we take off on today. This is actually one that synthetic division I told you about. This is an example that it can't handle. So I told you it was really, really quick, but that kind of normally means that there's only certain situations it works in. The little bit weird thing about this is there's a missing term sort of in the divider, right? Where'd it go? Here we go. And there's a missing term, more importantly, on top here. Okay, so we did an example long division yesterday, right? So this doesn't matter too much, but what really matters in here is that what's missing? What term is missing? X squared term. So what is it really? What's the coefficient if it's not there? 0. So when you write the inside, you have to do 3x cubed plus, minus 0x squared minus x plus 1. You need a little placeholder. And you might see why. It might not be necessary, but you just put it there in case, so you have somewhere to put the x squared terms if you get any. Right? So let's see, you guys remind me how this works. How do I figure out what starts this off? What do I put up here? Yeah. X squared times what is 3x cubed? 3x. I love it. You need a 3 and you need one more x. Let me stop there for a second. This is exactly what you do with normal long division of numbers. If you don't believe me, then just try it, right? So yesterday we had an example. Let's say it had 71 into 652,987. Yuck! What would be your first step here? Take a second and try to figure out what would your first little step be. And your first step can't be a step away from the problem. I would take a step this way, continue on. No. Yeah, you don't do 71 into something. Holy shit, I don't know my 71's times tables. Right? I know math really well. I don't have freaking 71 time table. So I think 7 into 65 to give me an idea of what to try. And what would that be? 9. Good. 9 times 71 would be 63. 9 times 1, 9. Right? And then you change the sign. I say that in a weird way just because it makes a little more sense with what we have to do here. So I do the exact same thing. I don't try to do this. I look at this. X squared times what is 3x cubed? 3x. And then like we did there, 3x times x squared is 3x cubed. 3x times 1. 3x, and it's going to go over here. And then what did we do there? The one that is really easy to forget. You have to change the signs. You have to subtract, which means change the signs. I like it. So, of course, these go away. There's nothing here. It was just here in case I needed it. And then here I get
Minus 4x.
Yeah, negative 4x.
Plus 1.
I like it. Now, here's the neat thing. Because this is tied into how the hell do I know I'm done? Right? Well, I know I'm done when this will not go into this, and that's currently what's happening. Right? Do I multiply x squared by something to make it 4? No, I would divide it. I can't make it go in, so I'm done. Now, the real question becomes, okay, what the hell do I do now? Right? And what do we do over here? Let me make this a little bit nicer. Remember. All right. So if we do this and then we subtract, we get 13. And then what do you do? Don't give me no big old R's. That's a long time ago. How do I write the rest of that answer? 13 13 divided by the thing you divided by. So what would this be? This would be 3x and negative 4x plus 1 over
X squared plus 1.
x squared plus 1. Now, I know it doesn't look as nice, but do you guys see what I mean when I say the steps are the same? That's what people don't believe me about. They're like, that's not the same. No, they don't look the same, but the steps are the same. Okay, I like it. Okay, not
Can
too
you
many
give
of
an
you.
example of that, like slightly more slowly?
Sure. Let's see.
I guess where I got confused was when you added 3x after you subtracted the 3x to the third. I didn't know where that came from.
This here?
Yes.
So when I put something, we did 7 into 65, right?
Yes.
And then we put 9. But we didn't just do 9 times 7. We did 9 times 71, right? So here we did x squared into 3x cubed is this. Then I do 3x times this. 3x times x squared is 3x cubed. 3x times 1 is 3x.
Got it.
And then I change the sign.
Okay.
So to get an idea of what to put up here, I can look at a part of it the same way we do with the number. It's the exact same thing. But then when I multiply it, I better multiply by the whole damn thing that's here. Can't just go, well, screw the 1. If the 1 wasn't here, it'd be a lot easier. Oh well, too bad it's there. Okay, maybe. Let's do another one here. Let's see. What if I had... Sure, I'll express. This is one we're going to learn a shortcut for today. Just because you learn the shortcut doesn't mean you don't have to know the other way. I'm just going to ask you both ways. We don't know the shortcut yet, so shit, we got to do it the long way. What do I have to be careful about as I write this? Yeah, there's no x4s. So then I got plus 2x cubed. And there's no x squared. Then I got minus 7x plus 5. Coolness. Okay. So those are just placeholders in case you need somewhere to put that term. If they weren't there, it's like there's nowhere to put it. Or you might make mistakes like combining things that aren't like terms. So x goes into... Oh, hello. Here's a good one. Ooh, get nice and high. X goes into 4x to the fifth what? X times what?
4x.
4x to the fourth. I like it. But then you got to multiply this by this whole thing, right? So 4x to the fourth times x. 4x to the fifth. Of course, that's where it came from. 4x to the fourth times negative 2. Thank God I put that there so I have a place for it to go. I don't make some silly mistake. Switch the signs, kick ass. And now these, of course, will always cancel. That's part of the idea. Those have to cancel, and here I get x4. That's awesome. You guys try to continue that.
Plus 2x.
No, I mean on your own. Hopefully you've been writing the problem down in your notes. I'm sorry? So I take this and I multiply it by this, all right? So 4x 4 times x is 4x5. 4x 4 times negative 2 is negative 8x4. Yeah, it's exactly the same idea as I use the 7 to figure out 9, but then what do I multiply 9 by? Not just by the 7, it's a 71. So this is not just x, it's an x minus 2. Cool. I like it.
I was just looking at the x by itself.
I got you. All right, let me catch up to you guys. So here I got to bring down the plus 2x cubed. Now what do I put up here now? X goes into 8x4, 8x3. I like it. X cubed. 8x cubed times x is amazingly enough exactly the thing we just did. And then 8x cubed times negative 2. Negative 16x. Switch the signs. I love it. Bam, bam. And why do I do that? Because that's what we freaking do, right? It's sort of like we're seeing how much of the number is left to have to be taken care of still. How much of the polynomial is left. So here I have, those go away, of course. 18x cubed. Bring down the minus 7x, right? You can bring down the plus 0x squared for a placeholder. Minus 7x. So then I look, these numbers get big pretty quickly. Yeah, I need 18x squared. It's kind of nice when it's just an x here. It's whatever the number is, it's going to be a part of what I need. Yeah?
Can you explain to me why the 8x cubed times negative 2, why that comes out to positive 16x?
It didn't. You see the little black line?
Yeah.
So this came out to be 8x cubed times x is 8x4. 8x cubed times negative 2 is negative 16x cubed, but then what do? Subtract it, so I change the sign.
You're changing every single sign in that row.
Exactly.
Okay.
Where did I leave off? Oh, here. So then I get 18x cubed minus 36x squared. So I didn't even need to bring that down yet. Switch the signs, I love it. Those go away. 36x squared minus 7x. And eventually I'm going to bring that 5 down in the next step. Oh my God. So yeah, when it's a 5th degree, you know it's going to be a little long. But do you see, I mean, the idea, so what is long? Once you get the process, you just keep redoing the process, redoing the process, redoing the process. I like it. So now I look again, I'm going to need 36x. 36x times x is amazing enough the thing we use to find it. 36x times negative 2. Negative 72x. Change the signs. 72 minus 7. It's 60. Got it. 65x. Bring down the 5. Whee! And finally, you need a 65. Do you guys start to get a feel for it? The thing that people forget are the poor little placeholder dudes, and they come in very handy, so don't forget that. And people just start to lose faith in the process, and they think it's supposed to change. It's not.
And then you toss the remainder, right, as the numerator. I just want to make sure I got that right.
Yes, the 65. So let's see, let me bring this up here. 65x plus 5, we'll get 65x minus 130. Change the signs. I get 135. So how do I put that at the end?
135 over x minus 2.
135 over x minus 2. I love it. Because we're way past the big R days, right? Hey guys. What happened? I love, if you're with me here, you have to be with me the whole way. Because what I did up here is exactly the same thing I kept doing and kept doing and kept doing. It's exactly the same thing. So what did I do to get to there? I said that times this is this, and then I multiplied that through. Saw what I had left. That times this is this. Multiplied that through. See what I had left. I just keep doing that over and over. The exact same thing we do when we divide numbers. Okay. Oh, you guys love it. Okay. So we are going to learn something that will make this process, this problem especially, would be a lot quicker if we use synthetic division. Let me see. Are there any other questions from homework stuff? Besides, we're going to do some more of this. So if you're still stuck on the long division, we are going to do more because I want to get us into synthetic too.
Could you maybe do number 40?
Oh, sure. I'm going to leave that there for later. Oh, this one, x to the fourth minus 18x squared plus 81. Okay.
I started by subtracting 81 and then factoring
Oh,
out.
yeah.
Maybe not?
No.
Okay.
Let me ask you this.
Yeah.
If I tell you I have two numbers that multiply to be 8, do you know anything about either one of these numbers? No. It could be 4 and 2, it could be 2 and 4, it could be 8 and 1, it could be 16 and 1/2, it could be 800 and 1/100th. Any two numbers that multiply 8, how many possible answers are there? Infinite number. But if this number is a 0, then I know that one of these has to be 0. So that's the number I want here. And really, what is the trigger? Why do I suddenly have to solve equations differently? Jeff, what the hell? We learned how to solve equations. You get the x's on one side. We know this shit. But the problem is, can you get your x's together? No. Shit, I need a new way to do it then. So you factor it how it is. Now, don't freak out about that. This works because, what would you put here and here to make x4?
X squared.
And thankfully, that is exactly what the middle term has, right? Think about this. As long as that power is half of this power, you can try to do this. Because what's the first thing you would do this is cut it in half, right? So what numbers work?
Minus 9 and minus 9.
Yeah. And each of these,
They're the same. So it's
well, each of these is a difference of squares. And how do you do that? And you'll get the same things there. Let me see if you guys are cool with this.
Yeah.
Want to get another x plus 3? Want to get another x minus 3? I mean, not write it like that in case you're not cool. This one will become x plus 3, x minus 3, right? So then either x plus 3 is 0, or x minus 3 is 0, or, oh yeah, I just said these, right? You're going to get repeats. So I don't know if you guys remember, there's a fundamental theorem of algebra. It says that I should get 4 answers. And I will get 4 answers, it's just that there's a couple of repeats. It's still valid. So what answers do I get? Either x is
3 or negative
3 or negative 3. There's another negative 3, there's another 3, so there are 4 answers. There's just a couple repeats. I went too far now. Can't stop myself sometimes. Okay, maybe. See, this is the thing you need to do. I tried to start to get you to realize this yesterday. You need to ask why things have to work the way that we say they do. Don't just take my word for it. Of course, I'm more than likely right. But who gives a shit? You got to really buy into it yourself. And you got to go, this guy seems to know what he's talking about, but who knows? He might go off the deep end, maybe didn't take his meds this morning. Sometimes I feel that way. Okay, cool. Anything else from homework stuff? Yeah.
48.
Ooh, I like it. Yeah, this one's a little weird, trying to relate what they're asking you to the equation. Right? Like, what does it mean to, does it ask for hitting the ground? Yes. What does that mean? Shit. Is everybody cool with this one here? I'm trying to save that one to be an example of the old way versus the new way we'll learn today. Okay. So they give me this formula, and hopefully you guys, I have a shirt that's got this little dude shooting a basketball. If you throw something up in the air, it's going to follow a parabolic arc, right? So the vertex would be the highest point if it's a down parabola. You guys kind of with me a little bit? So this will be parabolic. Hit a golf ball, right? I don't play golf, so that's why I just did that horribly. And it's going to have, you can slice and all that kind of shit, but it's basically going to be a parabola. So they've got the height, 64 times how long you wait, minus 16t squared if they did it correctly. Good. This 16 is related to gravity. It's related to how quickly gravity stops your velocity and pulls you back down. So you go up, and then gravity goes, nuh-uh, and pulls you back down. Okay, that's enough of that, sorry. So it's 32 feet per second squared. Gravity acting on you. So that's, anyway, it's more than you got to know. So what's this h represent? Height. So part A says, when will this hit the ground? Well, if it's the ground, what's the height? 0. So part A, in English it says, how long will it take for this to hit the ground? Or when is this going to hit the ground? And in Mathish, that means, when will h be 0? Does that make sense? I mean, so it's translating. Math is a foreign language. You have to translate the question into something more math-related. Okay. Some of you guys, I can't read at all. So now just put a 0 in there, and that feels a lot like what we just did. Hopefully. Right? Can I get my t's together? No, they're not like terms. So I have to, it's equal to 0 already. Sweet. So I can go ahead and do what with this? Factor it. Okay, I'm going to leave that one for you guys to do. It's going to work just like the other one I had up here a minute ago. Not the same factoring, though. What kind of factoring do you have to do here? It's not 3 terms, it's only 2. And what do you always try first? Okay. Part B says, at what times is it 48 feet in the air? And why is it times? Well, parabolic arc, if it's 48 feet here, it's going to be 48 feet again over there. As it's going up through it, as it's coming back down through it. So that's going to be a couple of times it is. So instead of a 0 here, I'm just going to put a 48 for part B. Which means what? What's the very first thing I have to do then? Yeah, you could subtract 48. I'm going to give you a little hint. Do you see how all these numbers are divisible by something? Hell yeah, I do that right away, especially factoring. Holy shit, the smaller the numbers are, the easier the factoring is, right? Also, you want this term to be positive to make it easier, so I would actually add this and subtract this. And then divide by whatever goes into all the numbers. A little hint from me to you. But you know your first step, whatever the hell you do, is you get one of the sides 0. What told you to do that? Not just me. The fact that my t terms can't be put together. They have a different power. That's what tells you to do that. Maybe. You gotta like it when the problem tells you what to do. If only it happened more often. Okay, cool. Anything else from the homework section? If you haven't done it, if you don't have a book yet, that doesn't matter worth anything because there's a copy of the first homework on the website. So, not a good enough excuse to not have done it. Right? Okay. Don't start off in the hole already. Keep ahead of homework. Okay. Anything else before I jump into new stuff? Or actually, I'll tell you what. I want to do this right now. I might as well do this. Let me give you this. Let me see what you think about this. I went and printed out copies of that factoring handout just because it's so stupid important. All of Chapter 7 will be impossible for you to do if you don't understand factoring. So I don't say that just to make you feel really nervous. I say that so you know what the hell is going to happen. Oh, you got her in? Sweet. So again, just in case this looks like way too much overload of information, I tried at the very top to put a summary of the way you approach a problem You always do GCF first. That's why I call it the zeroth step. You always just take a minute and see if there's a GCF. And then you count how many terms there are. So hopefully it sounds familiar. 4 or more terms grouping. 3 terms could be surefire or just trial and error. 2 terms could be cubes or squares. I like it. And there's examples down there. So what I want you to do, since this is so important, one side of this has got some freaky looking stuff that we're going to talk about here in a minute. The other side has a factoring practice sheet. So we're going to do this, and then we're going to talk about synthetic division, and then we're going to take a break. That's my immediate plan for the future. So don't look at this side yet with the long division and synthetic division. Don't look at that side. Look at the other side with all the problems, factoring practice. So if you want to, I just want you to do these problems. You can do them alone, or you can work with other people. Either way. You can work with your other personalities. You have them. You work well together.